aberration theory. The equation that we explained for the image formation, which is 1 over f equal to 1 over SO plus 1 over SI, is only correct approximately. So SO is the distance from the lens to the object, which can be a tree, a car, a house, or anything else. And SI is the distance from the lens to the imaging plane, which can be a CCD, can be a wall that you image something on the wall and look at it, or it can be your retina. And this lens can be your crystalline lens into in your eye. So this equation is only correct approximately. Now let's talk about what is that approximation. The approximation is correct when the rays are close to the optical axis, meaning the beam hits the lens surface, or any refractive material at a very small angle. And we usually use word paraxial for this kind of beam. So when the beam is paraxial, means that the beams are pretty close to the optical axis. So most of the time when we use par or para is a prefix that means something that is alongside something else or close to something else. So paraxial means the beam that are very close to this axis, and axial here means the axis, the optical axis. So those kind of beam, we call them paraxial beam or paraxial approximation when we are using this kind of approximation. The branch of optics that deals with this kind of approximation is called Gaussian optics, which deals with the beam that are pretty close to the optical axis. So now let's talk about the error that we can see from this kind of approximation, that we call it different kind of aberration. Mathematically, the power expansion of sine and cosine is given by this, which is a Taylor expansion of sine and cosine. So when the theta is pretty small, we can say x to the power of 3, which here is the same as x, it gets to a very smaller value. When it goes to the power of 5, again get to a very smaller value. For example, let's say x is 10 to the minus 2. This is a small value. Then it goes to 10 to the minus 6, gets smaller. Then goes to 10 to the minus 10, again much smaller than the previous one. So for cosine is the same. We start 1 minus x to the power of 2 over 2 factorial plus 1 plus x to the power of 4 over 4 factorial. So these terms can be, if x is pretty small, we can neglect these terms. So if we neglect those terms, we can say this is a Gaussian optics and or first order approximation. So when the first order approximation is valid, we can say this is a perfect imaging system. And when the angle increase, this deviation from this approximation known as aberrations. So any kind of aberrations is a consequence of this approximation. So we have, for the first order, we only take care of this part of the beam, but for higher orders, we have those terms. And all aberrations we have in our optical system comes from neglecting those terms. So sometimes we say we are doing first order calculation, which is based on these two. Third order, we actually have another term. Have a third order, we can fifth order, and so on, so forth.